I'm assuming you clicked on this because you have just purchased a Link ECU or planning on purchasing a Link ECU, either a plug and play or full standalone unit. Congratulations, they're one of the best ECUs on the market, and this YouTube series is going to show you how to get the most out of your new ECU. And I have a Link ECU on my personal car. It's a AP1 Honda S2000 with a supercharger. And in my opinion, I think I got my car to the point where it actually runs and drives better than the factory ECU. So I'm going to go through step by step and show you guys all the way from the basics to more advanced topics, how to get your car running as well as mine does. And if you guys have any questions, let me know in the comments. I'll try to answer them the best that I can. And I've done a lot of research, looked in the forums, and read all their documentation. And I'm pretty comfortable with sharing some of my knowledge that I have on the Link software. If you could spend 5 seconds and like this video, that'd be awesome. If you want to subscribe, I'll be releasing 15 to 20-minute intervals of this series explaining different modules of the application and different sections of it. And we'll go through a lot of detailed tuning stuff. As soon as you download the PC Link software for your specific model, there are two different models. I think the G4 Plus and G4X. So just make sure you download the right software for yours. But the first thing you're gonna have to do is actually unlock your ECU. I don't have an ECU connected at the moment, but you'd come up to ECU controls and unlock. So you'd have to get a code from the vendor that you purchased your ECU from, and that's just a theft deterrent. Okay, so people that are new to this software, this is an extremely important step to understand. When you plug in the ECU and you don't have a file open, that's going to default to opening the configuration that's stored on the ECU itself. If you have a file open already in the software, a configuration file, and you connect the ECU after the fact, it's going to come up with a prompt saying, do you want to store this configuration that's on your PC to the ECU? So when you get your link, I would suggest plugging it in first and not opening any base map and downloading and backing up whatever is on the ECU from the factory before you start anything. So when you plug in your ECU for the first time, it's actually going to say connected up here and the bit rate in this corner. If it's not, then you have some sort of connection problem, but it's going to load in that configuration file that's stored on the ECU, like I said. So in order to store that from the ECU to your PC, you're going to want to come to File and then Save As, and then you can name that file whatever you want. I would suggest keeping a new folder on your desktop or documents to keep all your tune iterations as you go through in a safe place. Second step is you're going to want to identify what configuration your ECU shipped with. So if you have your configuration open and look at under the basic configuration, you're going to see how many cylinders, how many stroke motor it is, and you can sort of identify if you have the correct base map loaded in for your particular engine. Now, if you don't have a plug and play and it's a generic ECU, you can actually just go to File, Open, and in the default folder under base maps, it's going to have a whole list of base maps that you can start from. And I believe there are even more from the link forums as well that you can download base maps from. You would either choose one of these or work from what was shipped to you on the ECU itself if you have a plug and play. So I'm actually going to come up here and open my specific tune that I've been working on for a long time now on my S2000. Multiple iterations to get this thing running as smooth as it does. And first thing you're going to want to do here before you even try and start up the car or anything is, and you can actually click this little pin on the left-hand side to always keep this ECU settings expanded. So if you don't have any of these tabs at the top, you can click on any of these and it'll bring up this configuration pane usually. And then you're also going to want to have the help browser open. So it's cool. Once you click on any of these parameters, it'll present to you the help section and what each of those parameters actually does. So if you need additional help in addition to these videos, or you have some obscure setting you're trying to set, you can actually look side by side with the help browser and it'll kind of point you in the right direction. So starting from the top, we're going to look at the base configuration. Just again, make sure all of these settings look correct, and this is a cool feature too, this memo text. So as you create iterations of your tune, so I could say like V1 sensor setup, you can actually take notes of each tune iteration and it'll keep track of what you did in each tune. So as you go through your versions, instead of doing it in just the file name or something, you can actually keep track of all of your notes in this memo under configuration. You have your firing order table, so just make sure that's all correct. And then we're gonna skip fuel for now and move into analog inputs and digital inputs. For all of your analog inputs with any standalone ECU, you're gonna wanna go through each one of these inputs and verify, especially in a base map, or if you're setting up an ECU from scratch that's not originally supported. You can even run these on like motorcycles and crazy rotary setups. So just make sure, especially because you put your engines together, you know what sensors are on the motor usually, or if it's a bone stock car, you can actually pick from a predefined list of sensors for each one of these. So some of the more important ones, like your map sensor, you can have your source and then your error high and low, and it's actually important to set these up. Usually these are 0 to 5 volt references for most of these sensors. So if you're getting anywhere close to the high or low range, it can actually throw an error on the ECU and let you know, hey, something's wrong with the sensor. This error value, you can also trigger, for example, this map sensor is reading higher than a certain range. So let's say you have a 1 or 3 bar map sensor. If it's going past 3 bar, you know you have an issue. So you can set that up as well. And then the most important part is this calibration. For example, I'm using the built-in map sensor, and this was shipped with the ECU with this base calibration with this. So they have all kinds of sensors built in, but the cool part is if you don't actually have one of these predefined sensors, you can set up your own configuration table. So I'll show you how to do that next. So don't worry too much about setting a custom table yet. You have all these calibration tables and linear calibrations you can use at your disposal. So don't select that just yet. So we're actually going to go down into calibration tables, and then we're actually going to pick an empty slot. So let's say calibration 2, and then you're going to call this something. So I can call this like Omni 4-bar map, and essentially you would input the values from the manufacturer. Usually they'll supply the high and low values, what sort of units they measure in, and at 0 volts, what it's reading, and 5 volts, what the reading is. So once you have that defined, you can actually come back into your map sensor and then pick that from the list. So we should have this Omni 4-bar map sensor defined here. So that's how you can set up custom sensors. You can do that with all kinds of different pressure sensors, temperature sensors, anything that you can connect to the ECU and is controlled by the ECU, you can set up any sort of calibration for those. Okay, so once you have all of your sensors set up correctly, or if you're just running a base map with a plug and play, you would actually come up to ECU controls again, and you're gonna calibrate your throttle position sensor. So this will tell the ECU at what position or what voltage 0% throttle is and 100% throttle. So just click on that menu and read the prompts on the screen, and it'll tell you press your gas pedal, depress it, so on. And then you're also going to want to, anytime you install a new map sensor or a new calibration for a map sensor, or if you just ship or receive one of these ECUs, you're also going to want to calibrate your map sensor. And what that's going to do is reference the barometer sensor that's on the ECU to the map sensor reading when the vehicle's off. So those numbers should actually match because you're just running at atmospheric pressure. So the barometer on the board of the ECU and your map will then match after this calibration is done, and you'll get a much more accurate reading. If your barometer and the map sensor in your vehicle are too far off, I believe it's like 5%, it's going to throw a code, and I believe it'll stop the engine from even starting in the first place. So if you're having that issue, you're going to want to make sure you calibrate that map sensor. And you can actually see down here as well in the parameter list, you can see the map sensor value right now and the barometer sensor, what that's reading. So you can see that these two numbers are close together right now and that my sensor is calibrated. Now, again, all of these steps are before even starting up the vehicle for the first time, and we have other parameters to cover as well. So you have to go step by step through all of this process before you can even turn the key. And you'll really want to make sure, in addition, that your engine protection values are set up correctly as well. So starting with the RPM limiter, rev limiter, you can either do ignition or fuel cut, and you can add some more advanced settings, but most people keep this to either ignition or fuel. And then the rev limiter table is actually this RPM limit table 1. So you can see here, mine's set to 9200. Now you have to keep in mind that there is a 200 RPM sort of buffer. So it'll actually start cutting ignition or fuel right before 200 RPMs lower than where you set that value. So that's one problem I was having, was even though I set my RPM limiter to what I wanted was 9,000 when the motor is warmed up, it was never actually reaching that because it was hitting its 200 RPM buffer there. So whatever your RPM limit is, I would say like do some logging and kind of ramp it up, but mine was technically 200 RPM higher than what the actual limit should be. So just take that with caution. One other thing I do as well to kind of indicate if something's running wrong with the car is above about 110 Celsius. This is engine coolant temperature on this top axis. So above where it's technically overheating, I'll start to ramp down this rev limiter. So if I'm at the track or something, and my car is overheating and I'm not looking down at that temperature sensor because I'm just focused on driving itself, I'll notice that something is wrong with the car because my rev limiter start going down to like 5 and 3,000. So this is a good safety to set up that not really many people talk about. You can also set your boost limit here. So again, what's going to happen when your manifold pressure is reached, and this for me is an ignition cut, and again your map table, and you can do this again based on engine coolant temperature, which is kind of nice to set any kind of boost limit. So if there's something wrong with your wastegate or wastegate line pops off, you're kind of protected there. You're going to hit some sort of limiter. Now with these tables, which is kind of interesting, is you can actually right click and say axis setup, and on your x-axis, so the top axis right now, you can actually set this to any sort of parameter that you want. So let's say if intake air temperature sensor instead of coolant temperatures is creeping up, you want to limit boost, you can actually come in here and type in intake, so IAT, and now your entire boost limit is based on air intake temp. So just make sure you change the values at the top. Obviously, you would do the same thing up in here, and then there you go. So you can modify pretty much any of these limits how you see fit or how you want to protect your engine. There's also a speed limiter. Some of these are fully customizable based on other sensors, so you can actually have something else trigger an RPM limit. There's also a voltage limit, but yeah, so just go through here and set up whatever makes sense to you. You can also, for these general RPM limiters, you can set them to be your oil pressure. So if you have low oil pressure, and actually mine's set to lean protection right now, so if the air fuel ratio dips below a certain amount at a certain map pressure, you can actually have a limiter there. But you want to set this up on oil pressure, you would again change this x-axis to look at oil pressure, and then this to another value, like let's say RPM. If it dips below a certain oil pressure, you can have these limits trigger as well. So if you are having some issues and you have set up some really complicated limits, you can also log those as parameters. I'll show you logging here eventually, but you can actually set those up as logging parameters and make sure that none of those limits are being triggered prematurely. Or if something's happening with your car and saying, oh, I'm hitting boost cut or lean protection or whatever, you can reference that back to logging. So I'm going to have entire other videos dedicated to fuel and ignition tuning, but I just want to cover some of the basic settings because whatever you choose here sort of locks you in, and I want to make sure you understand this up front before you kind of pigeonhole yourself into a corner. Usually you're going to leave this first parameter. So I am in fuel setup, and then fuel main. So this is your main settings here. This second setting is very important. Let me talk about this for a minute. There is 3 different methods of fuel equation. Okay, traditional is going to be more of a older Motec style, or if you're familiar with mega squirts, it's more of a time-based or millisecond-based pulse width opening, and you're going to have a master fuel value, which I'll talk about more in a minute, and the rest of your V table is going to be based on that. So traditional fueling is mainly for people that, one, don't have fuel temperature and fuel pressure sensors. So this was actually a big one for me because my ECU was initially set up under modeled multi-fuel, and I don't have those 2 sensors on my vehicle, and I've run into certain situations where my car runs a little bit strange when it gets hot or cold, and it can't really compensate properly and it just does all weird things. So if you are planning on running a modeled setup, just make sure you have those fuel pressure and fuel temperature, because those are going to play into the model itself, and that your air intake temp sensor is working properly. Basically, any sensor fuel related needs to be super accurate for the modeled version to work. Not saying it's bad, but it's much easier to run traditional fuel model. The other thing is, if you're running flex fuel, you're probably gonna want to go to multi-fuel or running methanol or multiple various fuels. If you're just running pump gas and only one kind of pump gas, then traditional works fine for that. So in my case, I actually ended up switching to traditional, and it worked out better in my case and a lot more simple, but that's really up to your applications. If you have the sensors to support it, I would say go modeled, because it is more flexible and it can take into account all kinds of fuel pressure changes or fuel temperature changes. If you're having like vapor lock, or your fuel rail is getting super hot and boiling the fluid, which can happen, this sort of thing can help compensate for that. So if we switch this to traditional, you're going to see that all of these parameters did in fact change. So leave everything else pretty much as is. Your master fuel here is going to be a little bit interesting to set up, but this is the primary function that traditional fueling runs off of. So this is, and if you look at the instructions as well, which is why I say have this open at all times, this millisecond value is the pulse width of your injectors at 100 kPa. So pretty much maxed out NA setup can reach like 80, 85 kPa of pressure. But this is going to essentially say at 100 kPa, how much is my injector opening? So this is going to play a direct role in your field table. So if you look at your field table, this is a VE table. These numbers are a little bit arbitrary and they don't truly represent anything other than the efficiency of your motor in relation to the other numbers. Should be a fairly smooth graph once you're done with it, but without getting into the weeds, and this is going to be in my next video, how to figure out what these numbers are for your fuel table. Just know that for your master fueling in milliseconds, you're going to want to get this fuel table to a point where in your idle sections of the map, you're at about 20s for value. The middle of the RPM range, I would say you want to be in like the 50 area, and anything in the wide open throttle, you're going to be near 100%. So when this number actually equals 100 and your fuel main master fuel is set to 19 milliseconds, that's how long your injector is open for when that value is 100. So if you need some more headroom or your V table is looking a little bit strange, so let's say these numbers to start with, and in mine set up a little bit high as well, I can definitely lower it. So I'm in the 40s at idle and I want to get down to the 20s. You would actually lower that millisecond value and your entire V table will shift. So you're going to want to make sure that you have this set up correctly if you're on a traditional fueling setup. And this will walk you through to this guide of everything that's involved with the calculation of it, and you can read through the details there. But again, we're going to cover this in the next video. And then as far as drivability goes, one thing I've noticed is turning this asynchronous injection on and lowering this minimum effective pulse width to 0.1 milliseconds. This is going to allow the ECU to have multiple fuel injection events per engine cycle. So it can actually spray fuel multiple times during that one engine cycle, which is kind of interesting. So this can actually handle a lot of your acceleration enrichment as you get into it, and drivability I've actually seen improved if you do this. Wall wetting, I wouldn't really mess with that. And here you can set up, if you're nearing your injector duty cycle, you can actually set this to, most people set it's like 90%. But I know in a supercharged setup, I'd never reach anything like that. So I just keep it at 100. Don't really care because I'm always running the same amount of boost. But if you're running a turbo and you're worried about wastegate line popping off and you're running crazy amount of boost and you're maxing your injectors out, or some environment variable changes and you're nearing injector duty, you can set that here as a safety. Here you have your actual injector setup, and this is going to be your injector dead time. So as you get a set of injectors, usually they'll have a table from the manufacturer of all the numbers to type in here. So this will add a dead time to the master fueling, adding or subtracting based on battery voltage. So once you have all that set up, you can actually test your injectors too. So I think this is a point where you can finally turn your key on and get into setting up some things and verifying that everything's working. So you would actually come up to injector test. You can pick any injector, and it's going to pulse for 2 milliseconds at 10 hertz. So it's just going to have a nice rapid pulse. You can hear that all your injectors are working, and you can cycle through each one and listen that everyone is working. You can do the same for ignition. So ignition test and test your ignition coils. And they're a little bit harder to hear, ignition coils, but if you put your ear up to it or put a screwdriver up to it in your ear, you can usually hear if those coils are firing off. Or I guess you could take the plug out and touch it near something that's metal and it will arc against it. Make sure you have spark. So that way you can check fuel and spark before you even turn it on, and your motor should turn around right away if those two things are there. Granted, you have compression. Some other things here, again, we'll get into the rest of the fuel setup in a later video because there's a lot of really cool features that I want to show you that'll make drivability amazing. Now, going back to this traditional versus modeled fueling. So mine was originally set as multi-fuel. So, okay, so this is gonna actually add a lot more detailed information about what kind of fuel you're using, the density of the fuel. It's a very scientific formula figuring out the model of gasoline or ethanol. So you're actually going to want to make sure you go through each one of these, and this will tell you uh, what type of fuel you're running and the actual density of it. All these values are pretty much, you don't have to guess. The documentation will tell you exactly what it is for each one. So don't want to cover that too much because it's covering the documentation and you can look through that. But as soon as you turn on modeled fueling, multi-fuel, or the standard one, all these values are pretty much going to match pump gas, I'm pretty sure, and auto fill that information in. All right, anytime you're setting up a aftermarket ECU, you're always going to want to verify timing. So if the ECU is commanding 10 degrees, you actually want to verify on your crank wheel that you're actually hitting 10 degrees and commanding 10 degrees and everything matches. The first thing you're going to do, and I would actually have your fuel pump turned off in this case, is look at your trigger scope. And my ECU isn't plugged in right now, but essentially that would pop up a screen, and as you're cranking, you're going to see oscilloscope, and it'll actually display the teeth cut out on your cam and crank trigger wheels. Sometimes you don't have a cam trigger wheel, but it'll show you the values of those, and you want to verify that all those settings are correct. And as long as that's all good, you can actually try and start the motor. So at this point, you're going to have a timing light, and you're going to stick it on the front of the crank, and there should be a mark at about 10 to 20 degrees, and you're actually going to come into ignition, and on your ignition table 1, you're going to want to look at your idle RPM and whatever the map value would be at idle, so probably somewhere like in this range, and just lock that value into, like, let's say like 10 degrees, whatever that crank value is. And you want to verify with your timing light that that 10 degree or 20 degree mark on your crank wheel is matching up with your 0 degree top dead center mark. So that means that the commanded 10 degrees is actually working. So yeah, I was wondering why I couldn't get to this calibrate menu where you actually set the trigger offset, but it was because my ECU isn't plugged in right now. But you would just come up here and search and type in calibrate, and it'll bring up this menu where you can actually set up base timing. All right, so that should be enough to get you started. And one last thing I want to cover is under logging, and you're gonna set up logging here, and you can log both with your PC connected. So up here in the right hand corner where it says PC log off, you would just click on that red bar and it would turn green, and it will store an ECU log on your PC itself under a specified file. The other cool thing is there is internal logging on most Link ECUs. So you come over to the ECU logging tab, enable it, and you can have all kinds of conditions where this is enabled. So as the memory buffer gets filled up with logs, it will just overwrite the oldest log. So you always have a capture of your newest, most recent log. So something mechanical happened, you can actually go back on the ECU itself, pull log, and figure out what happened in that event, which is kind of nice. You don't have to have a laptop hooked up anymore to do your logging. The only thing is just make sure that your parameter list is everything that you actually need and nothing more, because this can chew up a lot of your buffer space depending on how many parameters you're logging, and that both your PC logging and ECU logging, those parameters match. Because I've gotten to the point where I've done PC logging and I'm like, oh shoot, I forgot this parameter that my actual ECU was logging, and they are two different menus here. So just make sure that all of them are correct. All right, so that's gonna do it for this first episode. I hope you guys learned a whole bunch about setting up some of the basic parameters on your ECU. I would implore you to just play around with a lot of those different menus on the left-hand side and having your help menu open there and just seeing what other kind of stuff is available to you to tune and mess with. Just because I have mine set up a certain way doesn't mean that yours is always going to match or run exactly the same or what you need to do at the end of the day. So I implore you to do some self-learning, but until next time, second video I believe is going to be probably fuel tuning. There's 3 different methods you can use for getting your fuel table dialed in, and then the video after that I'm probably going to be doing a little bit of ignition timing and setting up your knock sensors. So stay tuned for those videos, but in the meantime, again, if you have any questions, let me know. This is a little bit longer of a video just because it's the first introduction video, but hopefully it wasn't too long for you and you got bored. Hopefully you guys learned something. But yeah, leave a like and subscribe for more of these videos.